Close your eyes for a moment and imagine this simple question. How much of reality do you think you are actually experiencing right now? Not how much you believe exists, but how much you truly feel, see, hear, or sense directly. The air around you looks empty, silent, still, yet you already know it is filled with radio waves, Wi-Fi signals, magnetic fields, temperature gradients, pressure variations, and invisible particles passing through your body every second. Even inside your own brain, thoughts appear as silent experiences, but underneath them are electrical pulses and chemical storms you never consciously witness. So what if most of reality is not hidden because it is far away, but because our senses were never designed to see it? And what if something as ordinary as a diamond could act as a bridge between what we feel and what actually exists? Humans evolved to survive, not to understand the universe. Our eyes detect only a thin slice of light. Our ears catch a narrow band of vibrations, and our skin feels pressure and temperature only within ranges that keep us alive. Outside that narrow window lies a vast ocean of activity, constantly shaping our world without asking for permission to be noticed. Magnetic fields guide migrating birds and shield Earth from cosmic radiation, yet we feel none of it. Electric fields orchestrate every thought you have, yet you never feel a neuron fire. Temperature differences ripple through materials at microscopic scales long before anything feels warm or cold. So why does reality feel solid and simple when it is anything but? And more importantly, how could we ever observe what our biology ignores? For centuries, humans built tools to extend their senses. Telescopes revealed distant galaxies, microscopes exposed hidden cells, and sensors allowed us to hear radio waves and see infrared heat. But even these tools had limits. They were often bulky, indirect, and separated from the very systems they try to measure. Measuring something delicate like a single neuron's magnetic field or a faint shift in gravity deep underground was like trying to hear a whisper during a thunderstorm. That is where something unexpected enters the story, something people associate with beauty and luxury rather than science. A crystal formed under extreme pressure, transparent and seemingly inert, turns out to be one of the most sensitive windows into the invisible world we have ever discovered. How could a diamond, of all things, become a scientific eye into reality itself? To understand why diamonds matter, it helps to rethink what a diamond actually is. Forget jewelry and status for a moment. At its core, a diamond is an incredibly ordered lattice of carbon atoms, each one locked into place with extraordinary precision. This rigid structure is not just strong, it is stable in a way that few materials can match. Vibrations that would disturb other crystals barely affect it. Heat passes through it efficiently, preventing internal chaos. And most importantly, this orderly structure can host tiny imperfections without collapsing. That sounds like a flaw, but in quantum science, imperfections are often where the magic happens. Why would a perfect crystal need a flaw to become extraordinary? Inside some diamonds, a carbon atom is missing and replaced by a nitrogen atom, leaving an empty space next to it. This tiny defect is known as a nitrogen-vacancy center, or NV center, but thinking of it as a technical term misses the wonder of what it represents. It is a single atomic scale system trapped inside a crystal, behaving almost like a tiny quantum sensor. This defect can interact with light, magnetic fields, electric fields, temperature, and pressure in ways that are incredibly precise. It is as if nature accidentally built a sensor smaller than a virus and hid it inside a gemstone. Why would such a tiny imperfection be so sensitive to the universe around it? The reason lies in quantum physics, but not the intimidating version filled with equations and abstractions. Imagine the NV center as a tiny compass needle, except instead of pointing north, it responds to invisible changes in its environment. When a magnetic field shifts nearby, the energy state of this defect changes slightly. When temperature rises, vibrations alter its behavior. When electric fields fluctuate, its quantum state adjusts. These changes are minuscule, far smaller than anything our senses could detect. But when scientists shine a laser on the diamond, the NV center responds by emitting light in subtly different ways. That light carries information, like a coded message from the invisible world. So what if you could read reality not by touching it, but by listening to how light itself changes? This is where diamonds stop being gemstones and start becoming translators of the unseen. By observing how the light emitted from these defects changes, scientists can map magnetic fields with astonishing precision, down to the scale of single molecules. They can detect temperature changes smaller than 1/1000th of a degree. They can sense pressure differences deep inside materials. This is not science fiction. It is happening now in laboratories around the world. But what makes this truly fascinating is not just what diamonds can detect, But where they can do it, these sensors are so small and stable that they can be placed right next to living cells, inside electronic circuits, or even integrated into future medical devices. So what happens when we start listening to the invisible signals inside the human body itself? Consider the brain, an organ often described as the most complex object in the known universe. Every thought, memory, and emotion arises from electrical activity, neurons firing and communicating through tiny currents. These currents generate magnetic fields, but they are unbelievably faint, billions of times weaker than Earth's magnetic field. Traditional brain imaging tools are either invasive, slow, or imprecise, but diamond-based quantum sensors can sit close to neurons and detect these faint magnetic whispers directly. Imagine watching thoughts form not as abstract patterns on a screen, but as real-time physical signals, seen through light interacting with a crystal. What does it mean for our understanding of consciousness if we can observe the invisible mechanics of thinking itself? This raises questions that go beyond medicine and neuroscience. If thoughts produce measurable physical fields, where does the boundary between mind and matter truly lie? Are thoughts just electrical storms, or is there something more emerging from this activity? Diamond sensors do not answer these philosophical questions directly, but they force us to confront them. When you can observe the physical signature of a thought, it becomes harder to pretend that consciousness is separate from the material world. Yet it also becomes more mysterious, because knowing the mechanics does not explain the experience. You can measure the magnetic field of a neuron firing, but that does not tell you why joy feels like joy or fear feels like fear. So are we getting closer to understanding consciousness, or simply uncovering how deep the mystery really goes? Beyond the brain, diamond sensors are opening doors in medicine that feel almost unreal. Many diseases begin with subtle changes long before symptoms appear. Cells alter their metabolism, temperature, and electrical behavior quietly, invisibly. By the time pain or discomfort emerges, the underlying problem may already be advanced. But what if disease could be detected at the level of single cells before damage spreads? Diamond quantum sensors can detect tiny temperature changes associated with cancer metabolism or subtle magnetic signals from abnormal cellular activity. This is not about diagnosing illness after it announces itself, but about listening for the earliest whispers of trouble. How would healthcare change if doctors could see disease forming instead of reacting to its aftermath? Think about what that means emotionally as well as scientifically. Early detection is not just about survival rates. It is about reducing suffering. It is about catching problems when they are still gentle, when intervention can be minimal. Diamond sensors, by revealing invisible biological signals, shift medicine from a reactive practice to a predictive one. But this also raises ethical questions. If we can detect potential diseases years before symptoms, how do we handle that knowledge? Does knowing too early create anxiety, or does it empower us? Technology that reveals the invisible does not just change science, it changes how we live with uncertainty. The same sensitivity that allows diamonds to listen to cells also allows them to listen to the Earth itself. Beneath your feet lies a complex structure of rock layers, faults, and hidden cavities. Traditional methods of mapping these structures rely on seismic waves or large magnetic surveys, which are powerful but coarse. Diamond sensors, however, can detect subtle variations in Earth's magnetic field caused by underground structures. This means we can map what lies below without drilling or blasting, simply by observing invisible signals. What if we could see underground water sources, mineral deposits, or fault lines with unprecedented clarity, reducing environmental damage and improving safety? This capability extends to monitoring volcanic activity, earthquakes, and even changes in groundwater flow. Small shifts in magnetic or gravitational fields can precede major geological events. Diamond-based sensors could act as early warning systems, sensing changes too subtle for traditional instruments. Imagine living in a world where we can listen to the Earth's quiet signals before it speaks violently. How would that reshape our relationship with the planet if we learn to pay attention to its invisible language? As astonishing as Earth-based applications are, diamonds are also helping us listen to the universe beyond our planet. Space is not empty, it is filled with particles, fields, and forces that shape galaxies and stars. Some of these forces, like dark matter, remain invisible not because they are far away, but because they barely interact with ordinary matter. Diamond quantum sensors are being explored as tools to detect subtle interactions that could hint at dark matter's presence. This is not about directly seeing dark matter, but about noticing its fingerprints, tiny disturbances in quantum systems that should not be there. What if the key to understanding the universe's missing mass lies hidden in a crystal grown in a laboratory? This idea challenges our intuition. We often think that to study the cosmos, we need massive telescopes and giant detectors buried deep underground. But quantum sensors flip this idea on its head. They suggest that the smallest systems, the most delicate quantum states, can be the most sensitive probes of reality. A single defect in a diamond might notice something that a kilometer-scale instrument cannot. This inversion of scale forces us to rethink how knowledge is obtained. Is bigger always better, or is sensitivity the true currency of discovery? The same properties that make diamonds excellent sensors also make them promising candidates for quantum computing. In quantum computers, information is stored not in bits that are either on or off, but in quantum bits, or qubits, that can exist in multiple states simultaneously. These states are incredibly fragile, easily disrupted by noise. Diamonds, with their stable lattice and isolated defects, provide a surprisingly robust environment for qubits. The spin state of an NV center can act as a qubit, manipulated with light and microwaves. This is not just theoretical. Working diamond qubits already exist. So what does it mean if future computers are built not from silicon chips alone, but from quantum states inside crystals? Quantum computing promises to solve problems that are currently impossible, from simulating complex molecules to optimizing massive systems. But beyond practical applications, it forces us to confront the nature of reality itself. Quantum states are not just mathematical tools, they are descriptions of how the world behaves at its most fundamental level. When a diamond qubit exists in multiple states at once, it challenges our everyday notions of cause and effect. If reality allows such strange behavior at small scales, why does the world feel so stable and predictable at human scales? Are we living in a simplified projection of a much stranger underlying truth? This question brings us back to perception. Our senses evolved to create a coherent story of the world, not a complete one. They filter, simplify, and ignore. Diamonds, in contrast, do not care about narratives or survival. They respond to physics directly. When we use them as sensors, we are, in a sense, outsourcing perception to matter itself. We are letting the universe tell us about itself without the constraints of biology. But can we truly understand what we measure, or are we just building more elaborate translations of something fundamentally beyond us? There is something deeply philosophical about using diamonds to see the invisible. Diamonds are formed under extreme pressure, deep within the earth, over timescales far beyond a human lifetime. They are products of conditions we cannot experience directly. And now, they are helping us explore realities we cannot sense. It is as if the universe left us a tool, hidden in plain sight, waiting for us to learn how to listen. But listening is not the same as understanding. When we detect a magnetic field or a quantum fluctuation, we still need to interpret what it means within our conceptual frameworks. Are those frameworks adequate, or will they need to evolve as our tools become more powerful? Consider how every major expansion of human perception has reshaped our worldview. The telescope displaced Earth from the center of the cosmos. The microscope revealed that life is built from invisible cells. Radio astronomy showed that the universe is loud with signals we never hear. Diamond quantum sensors are another such expansion, but this time the shift feels more intimate. They reveal invisible processes within our own bodies, our own thoughts, and the fabric of reality itself. When the invisible becomes visible, ignorance is no longer an excuse, but knowledge carries responsibility. How we choose to use these insights will shape the future in ways we are only beginning to imagine. There is also a quiet humility embedded in this story. For all our intelligence, we required a crystal formed by geological forces to teach us about the invisible. We did not invent quantum sensitivity. We discovered it hidden in matter. This suggests that reality is richer than our theories, waiting patiently for us to notice. It raises a subtle question. How many other tools does the universe offer that we have not yet recognized? If a diamond can become a quantum sensor, what other ordinary materials might hold extraordinary capabilities? As diamond-based technologies move from laboratories into real-world applications, the boundary between science fiction and daily life begins to blur. Imagine wearable devices that monitor your brain's magnetic signals to detect stress before you feel it. Imagine medical implants that continuously watch for the earliest signs of disease. Imagine environmental sensors that listen to Earth's subtle signals to prevent disasters. These possibilities are not distant fantasies, they are extensions of research happening now. But each possibility also invites reflection. Do we want to live in a world where the invisible is constantly monitored, measured, and interpreted? Does greater awareness always lead to greater well-being? At the deepest level, This story is not just about diamonds or quantum physics. It is about perception and reality. We often assume that what we experience is what exists. Yet again and again, science shows us that experience is only a surface layer. Beneath it lies a complex, dynamic, invisible world shaping everything we do. Diamonds give us a way to peer beneath that surface, but they also remind us of our limitations. Even with the most sensitive sensors, we still see through filters, models, and interpretations. Reality does not reveal itself fully, it offers clues. Perhaps that is what makes this moment so exciting. We are not reaching the end of understanding. We are uncovering new questions. If thoughts have measurable fields, what does that say about free will? If diseases announce themselves invisibly, how should we listen without fear? If the universe leaves subtle fingerprints in quantum systems, how much of reality remains hidden beyond our reach? Diamonds do not answer these questions, but they make them impossible to ignore. So the next time you see a diamond, consider what it represents beyond beauty or value. Consider it as a window, a translator, a quiet listener to the invisible. Consider that most of reality is happening right now without asking to be noticed, and that we are only beginning to learn how to pay attention. And then ask yourself, if we can finally see the invisible, how might that change the way we see ourselves?